the dark oxygen at the bottom of the sea.
A discovery announced in 2024, which promised to revolutionize our understanding of life in the oceans, is now under strong scrutiny by specialized scientists.
The original study, published in the journal Nature Geoscience, claimed that the famous polymetallic nodules-those rock formations rich in metals such as manganese, cobalt, and nickel, scattered across the bottom of the Pacific Ocean in the Clarion-Clipperton zone, thousands of meters deep, were producing oxygen in complete darkness, without any help from sunlight or living organisms. They called this phenomenon dark oxygen. The idea was fascinating. These nodules would act as a kind of natural battery, generating a difference in electrical potential between their metallic components and, with this, breaking down water molecules through a process called electrolysis, releasing oxygen and supposedly hydrogen. If confirmed, the discovery would change basic concepts about how oxygen reaches the seabed, where it was traditionally thought that it was only consumed by bacteria and animals, and would also raise discussions about the origins of life on early Earth. Furthermore, since these nodules are targets of underwater mining to extract materials used in batteries and green technologies, the findings suggested that removing these potatoes from the seabed could harm ecosystems more severely than previously imagined. However, in December 2025, an opinion piece published in Frontiers in Marine Science, authored by oceanographers, geochemists, and electrochemistry specialists, dismantled the thesis with compelling arguments. They pointed to serious flaws in the experiments. The chambers used to measure oxygen at the seabed were not adequately ventilated upon arrival, which may have trapped air bubbles or dissolved oxygen from the descent, releasing them later and falsifying the results. The initial oxygen concentrations inside the chambers varied greatly and were already higher than in the surrounding water, something that breaks basic rules of experiments of this type.
The strongest blow, however, comes from physics. The explanation given violates the laws of thermodynamics. Separating water into oxygen and hydrogen requires an enormous amount of energy. It's a reaction that goes uphill energetically and doesn't happen spontaneously without a clear and powerful energy source. Critics point out that no real mechanism has been demonstrated to provide this energy, and the study didn't even measure hydrogen, which should appear in proportional quantities if it were true electrolysis. In short, the hypothesis suggests that energy would be arising from nothing, which is impossible according to centuries of established physics and chemistry. Other previous studies, done with similar methods in areas with nodules, always recorded only oxygen consumption, never production. Unpublished data from the original group itself show an increase in oxygen even in tests without nodules, reinforcing the suspicion that it's all an experimental error, probably bubbles or sensor malfunctions. The authors of the original study, led by Professor Andrew Sweetman, state that they are preparing additional evidence and that a formal response is under review at Nature Geoscience. They also announced a new expedition to the site in 2026, with more advanced equipment, to try to definitively clarify what is happening. Meanwhile, critics argue that the article should be retracted from the scientific literature due to a lack of rigor and for proposing something physically unfeasible. The discussion remains heated. For now, the idea that the ocean floor produces oxygen in the dark thanks to metallic nodules faces serious objections and, for many experts, seems more like a measurement artifact than a true scientific revolution.